Welcome to MrCScience.com's video on acids and bases. Um, Acids and bases are fairly common terms, especially acids. We think of acids as something a liquid that dissolves stuff, so that you pour it on something and it dissolves it. Um, that, while it can occur, isn't necessarily the truth of acids. We're going to learn a little bit more about what acids and bases really are. It has to deal with a type of chemical reaction and exchange of a hydrogen nucleus. Um, when you think about acids, often the term pH comes up. Now, pH is written a little differently, lowercase p, uppercase h. The reason for this is this stands for power of hydrogen. Actually, the power is from the German word for power, which happens to start with a P too, so it works out pretty well. But it is a scale that we represent the concentration of hydrogen ions in a liquid. So you're familiar with pH. Let's see. Let's grab the scale here. So pH is a scale. Whoops. There we go. We'll go along a line here. In the center of that line, neutral pH is, as most of you already know, 7. And the pH scale goes from, originally went from 1 to 14. So here, let's give us a little bit more room to work here. So anything 7 was considered neutral. Anything below 7, oh, that's not a very straight line. Anything below 7 was considered an acid. Anything above 7 was considered a base or alkaline. So pretty much everything in the world falls into the acid and base, except for right in the middle is water, 7. And we're going to learn just a little bit that water can be either an acid or a base. So as far as liquids goes, pretty much everything falls into the acid and base category. Some of the strongest acids, battery acid. I believe battery acid is sulfuric acid, H2SO4, right around 1. Your stomach acid is a very strong acid. Hydrochloric acid, HCl, is stomach acid. Some things that go up here, lye, sodium hydroxide, we'll use often in our experiments. So lye is a very caustic base. Right around 13 is a concentrated bleach, is actually a caustic base. Get other things like acetic acid or lemon juice, or is an acid. We'll run across things on the base side, things like toothpaste can be basic. Shampoo can be run a bunch of different levels of base, and often they'll talk about pH balanced shampoo. That's what they're talking about. So that's one way to tell a acid from a base, is where its pH falls on that scale. Let's look at a different way. Okay, acids and bases have characteristics. An acid will taste sour. Now, I don't recommend that you use this test to test all the acids, because some acids are strong enough that they will destroy your your taste buds, and you'll taste sour for a second, but it'll mainly be pain. And also, many acids can be poisonous, so it's not a good idea to test things. But some of the things we're familiar with that taste sour, like we said, are the lemon juice and orange juice. Both have an acid in them. They're sour. Acids will conduct electricity. Remember, AQ means aqueous, when dissolved in water. They are covalent substances. You know that ionic substances from earlier will conduct electricity. Well, something like hydrochloric acid, HCl. There's no metal in here. That's a covalent substance. Sulfuric acid, H2SO4. There's no metal in here. Those are all covalent bonds. So covalent substances, acids will conduct electricity. And we'll learn that that's because of the hydrogen ion going on. Then there's a thing called litmus paper, blue litmus paper and red litmus paper. Blue litmus paper will turn red in the presence of an acid, pH less than 7. Bases, just the opposite, bitter. If you ever had the unfortunate uh, instance to taste soap or shampoo, it tastes bitter. That's one of the reasons why in the olden days says, oh, we'll wash your mouth out with soap if you keep on saying bad stuff. So it was a punishment. Slippery to the touch. Bases will be slippery. In class, when we work with lye, often when we're cleaning up, I'll tell the student to touch the lye and rub it between their fingers quick, then rinse it off right away. And they'll find that it is slippery. Turns red litmus paper blue. So that litmus paper is a test for acid or base. Blue litmus paper and red litmus paper. Okay, but none of that really tells us the chemistry of acid-base reactions. So let's start with our acids. Let's take our hydrochloric acid. Hydrochloric acid, when put in water, will yield. Now, acids are a hydrogen donor, hydrogen ion donor. You can also say a proton donor because a hydrogen is just a proton with an electron around it. So when you get a hydrogen ion, H+, it is just a proton. So they call it a proton donor or a hydrogen ion donor. So when hydrochloric acid reacts with water, what will happen is the hydrochloric acid will give up its hydrogen ion. So, and that hydrogen ion will actually bond to the water, making H3O plus. So an aqueous solution. And it will also generate chlorine ions. This is the reason that covalent acids will conduct electricity. You notice these ions now in here. So these ions, just like ionic compounds, will conduct electricity. So hydrogen donates its hydrochloric acid donates its hydrogen ion. Thus, it is an acid. It is a hydrogen ion donor. Another thing that we can look at from this, if we take sodium hydroxide, lye, a known base, add it to water. Actually, that's not a good example since it is ionic already. Let's back up here a little bit. Let's use another base. Let's use ammonia. So NH3, we add that to water. Oh, H2O, now I'm getting confused. Okay, and so what happens is because it is a base, it is a hydrogen ion acceptor. So it will become ammonium, NH4+, and that'll leave us with a hydroxy ion negative. So here the hydrochloric acid was a hydrogen donor. It donated that hydrogen ion. Here NH3 was a hydrogen ion acceptor. It accepted the hydrogen ion from the water. So now that leaves you kind of an interesting thing. In acid-base reactions, there's always an acid and there is always a base. You can't have one without the other. So even putting since hydrochloric acid donates a hydrogen ion, it's an acid. Guess who accepts the hydrogen ion? The water. So the water becomes the base. Same thing here. Ammonia accepts the hydrogen ion, thus it is the base. Water ends up donating the hydrogen ion, so it becomes an acid. So water can act as either an acid or a base. That is called amphiprotic. So it is amphiprotic. It can be either an acid or a base. So to identify an acid and a base in a reaction, we just need to see where the hydrogen ions go. Let's take our battery acid, our sulfuric acid, H2SO4, and let's combine it with calcium carbonate. CaCO3, calcium carbonate, also known as chalk. In this reaction, we will get, because it's ionic, we'll get calcium ions, but we will also get HCO3, which will have a negative charge, and we will gain HSO4. Both of these are aqueous, by the way, because ions can't really exist outside of water, and that will also be a negative charge. So what's the acid? Well, that's pretty simple. We use sulfuric acid, but you'll notice that sulfuric acid donates one of its hydrogens. So it has two hydrogens here. It's only got one hydrogen here. So it is the hydrogen donor. So it is the acid in the reaction. So where does the hydrogen go? Well, since we got two hydrogens here, we got one, we got two, it ends up attaching to the carbonate, which is part of the calcium carbonate. So in this case, the calcium carbonate is called the base, or often a buffer is what it's called here, but that's a little advanced for you. So you'll notice the carbonate gains that. So this is the base and this is the acid. So always look for where the hydrogen is going. Let's do one of the on your owns here real quick just to see if we can identify the acid in the base space. So we got hydrogen bromide plus ammonia. Maybe I should be. Almost always acid-base reactions will be aqueous. It will be in an aqueous solution. So NH3 ammonia. Oops, that's a 3. That's in an aqueous solution. So when we combine those two, this may not be balanced, but we don't care at this point. We get ammonium, NH4 plus, also aqueous. And we get bromine ions, Br minus, also aqueous. Okay, so what's the acid here? Well, look and see where the hydrogens went. So each of these have hydrogens, but NH3 becomes NH4, so it ends up gaining a hydrogen, right? So if it's a hydrogen acceptor, or hydrogen ion acceptor, it is the base in the reaction. Hydrogen bromide ends up just being, or hydrogen it just ends up being bromine ions. So it lost its hydrogen, so it's the hydrogen donor. It is an acid. Okay, so what we're looking for in chemical reactions is what is a hydrogen acceptor and what is a hydrogen donor, and based on that you can figure out your acid and your base. If this isn't clear to you or you have any questions, always feel free to email me at mrc@mrcscience.com. Thank you.